for our project, we chose to do beating the Google CAPTCHA, the Google reCAPTCHA with AI. Our group leader was John Haag, and group members were Zachary Kovalenko and Thomas Shear. So what is a CAPTCHA? A CAPTCHA is an acronym for a completely automated public Turing test to tell computers and humans apart. To the right, you can see a couple pictures of a few examples of CAPTCHA. The picture in the top left is the CAPTCHA, Google reCAPTCHA that we chose to work on. Do you want to hit the next slide, John?
Yep.
So the Google CAPTCHA was based originally on the Turing Test, which was actually named after Alan Turing. Some believe Alan Turing to be the godfather of computer science and the pioneer of machine learning during the 1940s and 1950s. The original Turing test was based on the imitation game. What happens during the imitation game is a human questionnaire asks a series of questions to both responders and basically tries to determine if the person is a male or a female. And in the AI version of the test, a computer basically determines whether it's talking to a computer and not a human being. And today, many AIs can pass the Turing test, but the original CAPTCHA idea was based on the Turing test. You want to hit the next slide, Mr. John? There are many applications for a CAPTCHA. It differentiates between humans and automated users. It uses challenges that are easy for people and hard for automated machines. Some examples of what a CAPTCHA might be is recognizing distorted letters and numbers, clicking a particular area, identifying images, various audio challenges, math or word problems. There is an invisible CAPTCHA today that actually uses the activity of a computer's browser to determine whether the user is human or not. And some uses for the CAPTCHA are poll accuracy, limiting registrations, preventing ticket scalping, preventing bots from spamming review sites, message boards, and contact forms, preventing bots from purchasing limited quantity items, limiting web scraping, preventing money laundering, and preventing fraudulent transactions. So as you can see, the uses for CAPTCHA are limitless. So the version of the CAPTCHA that we chose to beat was the Google reCAPTCHA v2, which essentially on the right, you can see a picture of it, and it's just a box where the user has to click a check mark next to I am not a robot. It relies on an advanced risk analysis system, which uses Google cookies. So essentially, it will work best with a Google Chrome browser, but to ensure that an audio challenge or a picture challenge is not presented to the user. So in our project, this is basically how we split up our project. We had to research different CAPTCHA types and different ways to solve them in order to determine which CAPTCHA we were going to work on beating using artificial intelligence. The first thing that we had to do is data aggregations, which we had to take screenshots of the reCAPTCHA on different background colors, different sizes of the CAPTCHA, and different screens. And that part was needed for actually designing our object detection models so that our object detection could actually recognize when a CAPTCHA came up on the screen. Then we had to train our object detection models using the data that we gathered before. The next part, we had to do a good amount of learning because we ran into a problem with our machines not being able to run the programs that we needed it to run. So we had to learn how to use Google Colab, get better at Python, how to set up a Linux server, how to write a Python virus, how to use Python screen capture and Python mouse events. Once that was complete, we had to test our YOLO and TensorFlow models for accuracy. When we compared both models, we were looking for the best accuracy, the least loss, the best speed of detection, the time spent training versus accuracy. And at the last part, we had to actually create a bot that would, once the CAPTCHA is recognized, actually go over to the CAPTCHA and click the CAPTCHA window. And we did that using a screenshot of the current window where the CAPTCHA was, and using the coordinates of where the program recognized the CAPTCHA was, and then we actually clicked it using Python mouse events.
So our goal was to produce an object detection model for the Google reCAPTCHA. Click on the reCAPTCHA and to solve the checkbox. It's important to note that we didn't do the audio version or the 3x3 box that have multiple images. So we had our bot execute scripts. And why is solving a reCAPTCHA important? Because people don't want spam on their websites. So if we can figure out how to solve the Google reCAPTCHA, we can buy things with automated robots, which makes it a lot easier for us to buy things like Supreme or make a bot for a video game. So our object detection model is an image classifying software to detect custom objects such as playing cards, bikes, cars, or people. In our case, it was a reCAPTCHA. So what will our model do? It will draw a colored box around the object, label it with CAPTCHA, and show the percentage of accuracy that the computer believes that object is the CAPTCHA. Our solution was to create two object detection models. The first model that we created was the YOLO v5 object detection classifier, and that stands for you only look once. And we used version 5, which is the most up-to-date version of YOLO. Our second object detection model was a TensorFlow object detection model, which is a deep neural network, which uses concepts of the human brain to solve problems. We compared both object detection models for the best accuracy, least loss, best speed of detection, and time spent training versus the accuracy of the models. In our data aggregation phase, we took hundreds of screenshots of different CAPTCHAs in different spots of screens with multiple different backgrounds, different sizes, and it's important to have variation in these images because it helps our object detection model learn better instead of just remembering a specific image and knowing that it's there based on how we labeled the image. We had to label each image where we knew a CAPTCHA was. We had to create a bounding box around it so that later the computer could tell whether it was a CAPTCHA or not. The YOLO version 5 model was our first model, and we took the screenshots in our data aggregation phase, labeled each CAPTCHA. Each individual picture had to be labeled, so we had over 400 pictures that we had to label per each training model. From there, we split all of those pictures into a training set, a validation set, and a test set. For the YOLO V5, we took 70% of the model to train, 20% to validate, and 10% to test the model. The result was a model trained with 3,000 epochs. It took a little under 3 hours because we used Google Collaborate and a graphical processing unit, which significantly increases the speed at which we can train a model. And our mean average precision was 0.98, which is extremely accurate. Here are a couple pictures of our YOLO V5 model at work, detecting different CAPTCHAs in different spots. You'll notice that some of these have the "I am not a robot" is only encapsulated in the bounding box, and one of them in the top left is the full CAPTCHA. And the reason that we did that was the variation makes it a more accurate learning methodology for our neural networks.
For our second model, we chose to use TensorFlow, and it's the first step. We did the same as YOLO. We took a whole bunch of screenshots gathered in the aggregation phase, put labels around them, defining to the program where CAPTCHA was within the screenshot, and then we designated 80% of those images for training and the remaining 20% for testing. The result was a model that was trained overnight and reached 43,506 iterations, and the resulting loss was 9.8939 times e to the negative 4. Here you can see the localization and classification losses of the TensorFlow model. It varied widely, and in my opinion, we didn't gain much more performance after 20,000 iterations, but we continued anyways. Next slide. Here we're comparing TensorFlow versus the YOLO models, and you can see that the TensorFlow model was much more accurate. However, that is most likely due to the fact that we let TensorFlow run overnight, as its training process was actually slower, versus YOLO only ran for 3,000 iterations. Next slide, please. Once we decided to go with the TensorFlow model, we chose that because the TensorFlow model had the accuracy and detection time was actually faster. We implemented some software that would take a screenshot of the user's desktop, and from there we would feed that into the model. The model would give us back a dictionary of coordinate systems. We fed that into NUPY on Python, which broke that down into clean bounding boxes that gave us our upper, lower, left, and right bounds for each CAPTCHA. And then we iterated through those, identifying the first one that was detected with the highest accuracy. And we would move the mouse, and we found that you could click anywhere within the CAPTCHA box, and it would work. You didn't have to hit the checkmark box. Anywhere in that box works. So we would just offset the coordinates by 70 pixels down from the top and 70 pixels in from the left. And that worked mostly in the checkbox. Sometimes it would miss. But in our testing, we got it 100% of the time, and we were never asked to provide any additional information. Next slide, please. Here we have a few videos of the CAPTCHA or the program actually running. In the right two is the model running as the user would see it, if it was a simple user using it. You would load up the web browser, run the script, it would screenshot, calculate for a second, and then it would move the mouse and click the CAPTCHA. If you could please play those two videos. You can see the middle one's running there. It'll move the mouse over, and both of those will click. Click. And you can see both passed. The next one, you can see that I put a debug mode on, and you can see that both of those CAPTCHAs were detected. It clears and only picked the first one that it saw. Next slide, please.
Trying.
The rightmost one, we have 4 windows running with CAPTCHAs on them, and we've noticed that it seems to have a maximum of 3 detections. So you can see it detects the top left, top right, and bottom right, and misses the bottom left, and then clicks the top right. The one in the middle is just a really small window, and the one on the left is yet another test. This time I moved the PowerShell window just to give it a little variation on the screen. Next slide, please. This one we tested. CAPTCHA is known to give or ask for additional verification when connected to a VPN. So you can see we are connected to a VPN. We run the software, it grabs a screenshot, identifies the CAPTCHA, and the debug screen comes up. You can see it there, and clicks, and we get the check mark. A-OK, ready to go. Next slide. And these are our references.